Welcome to a video on solving quadratic inequalities. In this video, we're going to learn how to solve quadratic inequalities graphically using the free online graphing calculator, Desmos. Let's get started. Throughout this video, I'll be making several graphs using Desmos. All of the graphs used in this video are linked in the video description below. Please use the links to follow along with the video. Let's start by first examining the difference between a quadratic equation and a quadratic inequality. A quadratic equation has at most two solutions. Graphically, this is where the parabola and a line intersect. So for example, if we're looking at the quadratic equation, x squared plus x minus 2 equals 4, the left-hand side will be a parabola, and the right-hand side will be a horizontal line at 4. So where those two functions are equal is where the horizontal line and parabola intersect. In this case, there are 2 points of intersection where x equals -3 and x equals 2. So this quadratic equation has two solutions. Some quadratic equations have two solutions, some have one, and some have no solution. But quadratic equations have at most two solutions. Now, quadratic inequalities, on the other hand, potentially can have an infinite many solutions. Graphically, this is where the parabola is either above or below a horizontal line. So for example, let's take a look at almost the exact same equation, but let's turn it into an inequality. Let's look at x squared plus x minus 2 is greater than or equal to 4. When we looked at the equation, where it was equal to 4 is where the line intersected the parabola. But now we want to know where the parabola is greater than or equal to 4. So essentially we're looking at where the parabola is above the horizontal line. In this case, there are many places where the parabola is above the line. So whenever we have an infinite number of solutions, this is too many to list, so usually we use interval notation to write our solutions. Here's a quick reminder about interval notation. We use different types of brackets to denote which points are included or excluded. If we want to include a point, we use a square bracket for interval notation. Graphically, points that are included are represented using solid dots or a solid line. To show that points are excluded using interval notation, we use round parentheses. Graphically, we show something is excluded using an open dot or a dashed line. Now let's look at our directions on how to solve quadratic inequalities using Desmos, then we'll look at a few examples. First, enter the left and right sides of the inequalities as two separate functions, say f of x and g of x. Then click on the intersection point or points to reveal the coordinates. Determine the sections of the parabola that satisfies the inequality. In other words, you want to look where the function that you called f of x is either greater than g of x, meaning above, or where f of x is less than g of x, meaning below. This last point is very important. The solution to the inequality are the x coordinates from the region of the parabola that satisfies the inequality. Most often with quadratic inequalities, we'll be using interval notation because there will be so many points we can't list them. Let's take a look at our first example. We want to solve the inequality x squared plus x minus 2 is greater than or equal to 4. So we'll start by calling the left-hand side f of x. So f of x is going to be the function x squared plus x minus 2. And g of x is going to be the right side of the inequality. So g of x will be the function 4. Let's go over to Desmos and enter f of x and g of x into the cells on the left-hand side. Open your internet browser to the website desmos.com and then click on this button toward the top of the screen that says Graphing Calculator, or from the Math Tools menu, select the Graphing Calculator option. When the calculator first opens, you should be looking at a blank graph, and enter f of x and g of x into each cell on the left-hand side. If you need to, you can use the Desmos keypad located in the bottom left-hand corner. Let's enter f of x equals x squared plus x minus 2, and in the second cell, g of x equals 4. The next thing we want to do is we want to locate the intersection point of these two graphs. In Desmos, all you need to do to locate the intersection points is simply click on the point to reveal the coordinate. So these functions intersect at the point -3, 4 and 2, 4. For step 3, we need to determine which portions of the parabola satisfy the inequality. Remember, our inequality was x squared plus x minus 2 is greater than or equal to 4. This is like saying, where is f of x greater than or equal to g of x? So we're looking, where is the parabola above the horizontal line? It looks like there are two sections. Over here on the left, just to the left of the point -3, 4, the parabola is above the horizontal line. And to the right of the point 2, 4, the parabola is above the line. So it looks like we have two regions where the parabola, or f of x, is above 4, that horizontal line. One thing that's nice about Desmos is that it will actually shade the region that you're looking for. Let's go over to the third cell and let's enter our inequality in terms of f of x and g of x. So we want to find where f of x is greater than or equal to g of x. If you notice, it shaded the exact two regions that we found earlier. To the left of the point -3, 4 and to the right of the point 2, 4. The final step is to determine the solution. We write our solution in terms of the x values. So although we were looking at where the parabola is above the line, we want to describe the answer in terms of the x values where that occurs. So if we notice the first x value where f of x is actually equal to g of x occurs at the point -3. That's where the horizontal line and the parabola intersect. To the left of -3, all of those x values are points on the parabola where it is above the horizontal line. So if we describe this region shaded in green on the left, that would be where x is less than or equal to -3. On the right-hand side, we're looking to describe x values where our parabola is above the line. The first one occurs at 2. In fact, that's where the parabola and the line are actually equal. Then we want to describe the x values in this shaded region. These are going to be x values that are greater than or equal to 2. So to summarize, we graphed our inequality and we found where the parabola on the left intersected with the horizontal line 4 on the right. We determined the two regions where the parabola is above the line are for x values where x is less than or equal to -3 and where x is greater than or equal to 2. The last step is we want to describe these regions using intervals. So x less than or equal to -3 would translate to -infinity to -3 with a square bracket on -3 because that is included. And then from 2 to infinity, once again, a square bracket on 2 since 2 is included. Both -3 and 2 are included in these answers since our original inequality in the problem was greater than or equal to. And just a friendly reminder, -infinity and infinity always receive a round parenthesis. Now let's solve the inequality x squared plus x minus 2 is greater than 4. This sounds very familiar to the previous problem. In fact, the only difference is the type of inequality. We've changed from greater than or equal to strictly greater than. Let's see how the solution changes when we change the type of inequality. Once again, we'll keep f of x and g of x to be the left and right hand sides. The main thing that we need to do is we need to edit our inequality on the left hand side and change f of x greater than or equal to g of x to just f of x is greater than g of x. Let's make that change now. I've changed the inequality to a strict inequality. It may be difficult to see, but the only thing that changed was this vertical line at -3 and at 2. Instead of a solid line, they are now a dashed line. Dashed lines and open dots have the same meaning to us in math. They mean that those points or that line is not included. So we're still looking for values where the parabola is above the line. That still occurs in this shaded region where x is less than -3. The only thing that's changed here is we can no longer include -3 as a possible solution. Similarly, on the right-hand side, we're still looking for values where the parabola is above the line. That still is true for x values that are greater than 2. The only difference here is we can no longer include 2. So the main difference when you switch from greater than or equal to strictly greater than is you can no longer include those endpoints as solutions. So you could write the solution as x is less than -3 and x is greater than 2. We have two different regions where the parabola is above the line. That's why we have two different solution sets. In interval notation, this would be written as -infinity to -3 and from 2 to infinity. -3 and 2 are receiving round parentheses here because they cannot be included as solutions. We've looked at quadratic inequalities with greater than or equal to and strictly greater than. Now let's reverse the direction of the inequality. So for this third example, let's solve the inequality x squared plus x minus 2 is less than or equal to 4. Once again, we'll let f of x and g of x represent the left and right hand side of this inequality respectively. Can you guess at the area of the parabola we'll be looking at here? Let's go back to Desmos and find the solution to this inequality. Once again, we've entered f of x and g of x into the left hand side, and I've temporarily turned off the shading part for this inequality. Let's locate the region that satisfies the inequality first, and then we'll use Desmos to confirm our answer. In this case, we're looking for the inequality where x squared plus x minus 2 is less than or equal to 4. This is essentially like finding where f of x is less than or equal to g of x. Or in other words, we want to find where the parabola is below, meaning less than, the horizontal line at 4. It looks like this center section is the area that satisfies that inequality. That makes sense because the other two pieces satisfied the inequality greater than or equal to. Let's ask Desmos to shade the proper region for us and see if we're correct. Yep, it looks like when we add f of x is less than or equal to g of x to the third cell, it shades that region in the middle where the parabola dips below the horizontal line at 4. To describe our answer here, we're looking for all values of x between -3 and 2. In this case, we can include -3 and 2. That's because our original inequality was less than or equal to. To summarize, when we're looking to solve this inequality, we graphed both the left and right hand side, and we found that the parabola dips below the line for x values between -3 and 2. So our solution set, which is always the x values, are all the x values greater than or equal to -3 and less than or equal to 2. Converting this to interval notation, we would say that this is between -3 and 2, with square brackets on both -3 and 2 because those points are included. For our last and final example, let's replace less than or equal to with strictly less than. So let's solve the inequality x squared plus x minus 2 is strictly less than 4. We're going to continue to use f of x and g of x to represent the left and right hand sides respectively. Let's go back to Desmos and see how our solution changes. Let's go over to the left hand side and change the inequality from less than or equal to less than. I've now changed the inequality to less than. Just as when we were comparing greater than or equal to greater than, the only difference here are the endpoints. When I change the inequality from less than or equal to less than, those vertical lines at -3 and 2 changed from solid to dashed lines. Our solution is still the x values in the region where the parabola dips below that horizontal line at 4. We're looking for x values between -3 and 2, except this time we cannot include -3 or 2. We found the solution to x squared plus x minus 2 is less than 4, includes a similar region for x values between -3 and 2, except we cannot include -3 and 2. So we would write this in interval notation as from -3 to 2 with round parentheses on both -3 and 2 to exclude those points. Let's finish this video with summarizing what we've learned. The direction of the inequality, either greater than or equal to or strictly greater than, or less than or equal to, usually tells us we're looking for x values where the parabola is either above or below. In the first two examples where we were using greater than or equal to or strictly greater than, we were looking for the areas where the parabola was above the line. In the second two examples where we were looking at less than or equal to or less than, we were looking for the area where the parabola dips below the line. The type of inequality, whether it includes the equal to part, as in greater than or equal to or less than or equal to, versus the strict inequality, strictly greater than or strictly less than, tells us whether we can include or exclude the endpoints. When you have the equal bar below on the inequality, you can include those endpoints. For strict inequalities, the endpoints must be excluded. That's it for this video. Thanks for watching.